Chapter 8, Section 4, Similar Triangles. This first example says in the diagram, triangle LMN is similar to triangle PQN. If you notice in this diagram that they've given me, we have QP and LM are both, the top and the bottom lines are parallel. If you remember, anytime we have parallel lines, we should be looking for a transversal. We can use alternate interior angles, alternate exterior angles, and the fact that they would be congruent because those two lines are parallel to help us. A asks us to write the statement of proportionality. Remember, a statement of proportionality, especially in this case since we have a triangle, you're going to write ratios for corresponding sides between the two triangles, and you're going to set them equal to each other because the ratios should be proportional to one another. So if you look at this diagram, my corresponding sides, we would have QP for my bottom triangle would be corresponding to LM on the top triangle. QN would be corresponding to NM, and then LN would be corresponding to NP. So we can go ahead and write that statement of proportionality like so, noticing that corresponding parts, corresponding sides are making up the ratios. My smaller triangle, the QPN triangle, is on the top all the way across, and my LMN triangle is on the bottom all the way across of my proportion that I've just written. B asked me to find the measure of angle M and the measure of angle P. To find the measure of angle M, I can use alternate interior angles. The measure of angle M would be 36 because it is the alternate interior angle with the measure of angle Q, which they tell us is 36. To find the measure of angle P, first of all, I can say that because of vertical angles, because the top angle there is 106, the bottom angle QNP is going to be 106. And then I can use the triangle sum theorem to say that 106 plus 36 plus x, which would be the measure of angle P, equals 180. Go ahead and combine your 106 plus 136 is 142. I need to subtract 142 from both sides, and I get x is 38. So I can say that the measure of angle P is 38. C asked me to find MN and then to find QM. If you notice, MN is going to be corresponding to QN from my smaller triangle. And then I'm given that LM is 33 and QP is 30. So I can set up a proportion and say 30 over 33 is equal to 20 over MN. And just like before when we've been solving proportions and setting up proportions, there are several different ways that you could write that proportion. What matters is this next step. No matter how you wrote your proportion, if it is a correct proportion, you should have 30 times the measure of MN equals 660. When you divide both sides by 30, you get the measure of angle MN is 22. Because the measure of angle MN is 22, we can use the segment addition postulate to say that the measure of QM would be 20 plus the 22 that we just found, so that whole length from Q to M would be 42. The angle-angle similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. This is a similarity postulate, not a congruence postulate, so I want to point that out. All that's saying is that the angles are going to be congruent and the sides are going to be proportional. This example says explain why triangle WVX is similar to triangle WZY. The first piece of information that should be kind of sticking out at us is that they're telling us by notation that both triangles have one right angle. Angle V and angle Z are both right angles. And we know that all right angles are congruent. something that might not be as easy to see, but you can see it, is that the smaller triangle, WVX, and the larger triangle, WZY, both contain angle W at the top. So both triangles share angle W. I have two congruent angles, so I can say that because the triangles have two congruent angles, the triangles are similar because of the angle-angle similarity postulate. This next example says use points G and J in the diagram below to find the slope of the line containing segment GJ. Name 5 other segments whose endpoints could be used to find the slope of the line. The first thing that they asked me to do is find the slope of GJ. To find the slope from G to J, I need to count my rise over run. If you notice, G is in the second quadrant at -3, 4. J is in the fourth quadrant at 2, -6. So to go from G to J, I would have to go down 10 units, and then I would have to go to the right 5 units. So my slope from G to J would be -10/5, which I can simplify to -2. The next piece of this problem says name 5 other segments whose endpoints could be used to find the slope of the line. What that's basically saying is name 5 other segments that are on that line. So we have the whole segment GJ, but there are also segments GH. We could go from G to I. We could also go from H to I, from H to J, or then I to J. So that is 6 different points, 6 different combination of 2 points on that line GJ. This next example says in another camera, F equals 10 centimeters and N equals 6 centimeters. Use the proportion F over H equals N over G to estimate the altitude H in meters required to take a photo that covers a ground distance G of 100 meters. Basically, they've given us a proportion, and they've given us some of the pieces that we need in this proportion. They've told us that F is 10 centimeters, N is 6 centimeters, and that G is 100 meters. So go ahead and plug in what we know. Now we can cross multiply. 10 times 100 is 1,000, and then equals 6 times H. I need to divide both sides by 6, and you get H equal to about 167 meters. This next example says find the length of EH. If you notice, EH would be the altitude or the line going from E to H in the larger triangle. And then notice that we also have this smaller triangle in the inside of my larger triangle. What we can do is we can set up a proportion. We need to set up a proportion of EH would be corresponding to CF, which they tell us is 6. And then AD, which is 5, would be corresponding to AB, which we can use the segment addition postulate to say 5 plus 7.5 is 12.5. So I set up the proportion as 12.5, which is the base of my larger triangle, over 5, which is the base of my smaller triangle, is equal to x, which would be the altitude or the height of my larger triangle, over 6, which would be the height of my smaller triangle. Just like with any other proportion that we've talked about, we can cross multiply and we get 75 equals 5 times x. Divide both sides by 5 and you get x equals 15, which means the length of EH would be 15. Today's assignment is page 483, numbers 10 through 46 even, and then numbers 62 through 70 even.